Hello and welcome back to Quay Does Leetcode. Today I'm going to be doing problem number 100, same tree. So for this problem, you're given the roots of two binary trees, P and Q, and you need to write a function to determine if they are the same or not. So you return true if the trees are the same and false if the trees are not the same. So they're the same if they are structurally identical and the nodes have the same value. So they have the same parent-child structure and the parents and the children all match each other. So for this example, we can see that these two trees are the same. And why is that? Well, because they have a root of 1. This one has a root of 1. This one has a root of 1, so the roots match. And then we can check, and they have one child on the left, and it's 2. And this one has one child on the left, and it's 2. And then one child on the right, and that's 3. And this one has one child on the right, which is 3. So we can look at these trees and tell that they are the same, but how can we do this with a function? Well, we can define it recursively. So our trees are a recursive structure, and you can define this recursively where you can check, are their roots the same? So the roots are the same, and then do the left subtrees, are the left subtrees the same? The left subtree and the right subtree, is the right subtree the same? So for every node in the tree, you can check, is the root, considering the root at this being this tree, is this the same? And is the left subtree the same? And is the right subtree the same? So you can do that from the root. You can do that from the left node. The left subtree is just none and none. And this one also has none and none. And then so the left subtree is none, so the left subtree is the same. The right subtree is none, so the right subtree is the same. And then you can do that for node 3. The left and right subtrees are both none. And so the roots are the same, the left subtree is the same, and the right subtree is the same. So that is essentially the algorithm, the thinking behind it, and you can write this recursively like I mentioned. So let's see that in the code. So the first thing we'd need to do is take care of the base case. So if both of the nodes are none, if not P and not Q, then that means they're matching and they're the same. So we're going to return true. And but if one of them has a subtree, if one of them has something in it and the other one doesn't have anything in it, then that means they don't match. So after you check if both of them are not empty, then if you check if not P or not Q, then that means one of them is empty, but the other one isn't. So that's going to return false. And now you're guaranteed, after you finish these two cases, to have both of the trees have something in them. At least a root node. At least a root node. So now you want to check if their left subtrees are the same. So we're going to do self.sameTree is same tree is same tree. We're going to call this function on, and we're going to give it, we're guaranteed to have something in P is guaranteed to not be null. So it's going to be P.left, and Q is guaranteed to not be null also. So we're going to give it Q.left. And then we're going to check if the right subtrees are the same, and we're going to give it so we're going to call self.isSameTree and give it the right nodes to look at. So P.right and Q.right. And now all we need to do is check, remember, we need to check if the roots are the same, the left subtrees are the same, and the right subtrees are the same. So we're going to return P.val equals Q.val, and left subtrees are the same, and right subtrees are the same. So if all of those are equal, or if all those return true, then we return true. Otherwise, we return false. And that's the code. So let's run it. And we're getting a correct answer. Let's submit it. And that is passing, and it's pretty efficient. So for this, you would have to check all of the nodes in P and Q. So it would be, if they are, the number of nodes in P and Q are the same, then it would be O of n for the number of nodes for the time complexity. If one of the nodes, if one of P or Q had more nodes than the other, then the time complexity would be the max of the n of P and Q. And because this is recursive, we're going to have to make a stack of the height of the tree. So that would be O of h for the space complexity. This could be either, if it's an unbalanced tree, it could be O of n. You have to, if it's a skewed tree, or log n if it's a completely balanced tree. So that is how you solve that problem. Thanks for watching, and I'll see you in the next video.